Hello YouTube, this is Dr. Ronald W. Satz, founder and chair of the International Society of Unified Science and president of TransPower Corporation, a commercial and custom software manufacturing and certified systems engineering company. I work as a theoretical physicist and as a systems and mechanical engineer. I'm the author of the Reciprocal System Macrocosmos database, which you see here on the right, and the Reciprocal System Macrocosmos database. Last time we discussed the layout called the universe, and I'm going to click on that now. We covered all the fields, but we didn't cover the sub-layout here called estimated number of habitable planets and extraterrestrial civilizations. So let's go look at that today. I'm going to use the Drake equation, the well-known famous Drake equation, together with the principles of the reciprocal system to derive this number. The first aspect of the Drake equation, the first variable is r sub star. That's the rate per year at which stars are being formed. This would be 0.01. Now keep in mind that in the reciprocal system, by the way, that's in our galaxy, but in the reciprocal system, it's not possible for a star to form in the interstellar space between two stars, because each star has control of the matter within its gravitational limit. So this number of stars being formed has to come from absorbing globular clusters, either mature globular clusters or immature globular clusters. Okay, the next number is f sub p, fraction of stars with planets. We're going to assume here 0.5. In the reciprocal system, we start with one star, basically a red giant in a globular cluster. That contracts down to the main sequence and moves up the main sequence. It takes about 10 billion years to become an O or B star, which then explodes, creating a binary star system if the explosion is huge enough, or a solar system, in which case we get a red giant which contracts back to the main sequence and a series of planets. So either we get a red giant and white dwarf pair, or we get a red giant and a set of planets, and the red giant contracts back, eventually becomes a red dwarf, and then moves up the main sequence. So we're going to say about half the time we get planets. Okay, next number, n sub e, number of planets per solar system with an environment suitable for life. Based on our own solar system, we'll say 1.5. We have the Earth and possibly Mars or Venus, which may have had life millions of years ago. 1.5 seems to be the right number. Fraction of suitable planets on which life actually appears. I'm going to assume that this is 1, because if it's a suitable planet, it seems likely now that there'll be at least some form of life, at least molecular life, microbial life, I should say. Okay, f sub I, it's a capital I there, fraction of life, I'm sorry, that would be, yeah, f sub I. That was f sub I above. This is f sub I. Fraction of life-bearing planets on which intelligence emerges. Evolution is directed toward intelligence. That's really the final goal of evolution, is intelligence, because it aids with survival. Remember, the main point of biological organisms is survival. Intelligence aids that, so it can take this fraction as actually being 1. Then we have f sub e, which is the fraction of intelligent societies that develop the ability to communicate with the desire to communicate with other worlds. Again, we're going to assume 1 for that as well. And then finally, longevity in years of each civilization in the communicative state. We'll assume 2 billion years here. Past 2 billion years, the star will get hotter and hotter, making it more and more difficult for intelligent life to survive on its retinue of planets. So 2 billion years seems to be about right. So n is the output of the equation, the number of civilizations on our side of the galaxy that are currently capable of communicating with other solar civilizations. So we get 15 million here. Now, we're going to assume that 1/3 of all galaxies are spiral, which are the only galaxies suitable for intelligent life. Now, why do I say that? I say that because in the larger spheroidal galaxies, the radiation, the intensity from the center would be so great that life would only be possible in the far outskirts of such huge galaxies. So it's kind of dubious that any life would still exist in these huge spheroidal galaxies. Now, for example, our local group contains somewhere around 67 galaxies, which will eventually combine to form a giant spheroidal galaxy. That will probably put an end to life in a galaxy unless it's way out in the suburbs. So we're going to say that spirals are the only place. And the ellipticals and dwarf galaxies and galactic clusters are, of course, too small and too young to have any kind of life. Now, we're going to assume that the average spiral galaxy has 200 billion stars like our galaxy. Then, considering both sides of each galaxy, these grand totals result. So we have to multiply this result by 2 to get 30 million, because after all, we're only looking at our half of the galaxies. And so the estimated number of material galaxies, M galaxies, would be, well, we're assuming, again, this number here is the number of galaxies estimated to be in our material sector of the universe is 100 billion. Same thing with the cosmic or C galaxies. So this results in 3.0225 times 10 to the 18th number of M galaxies, and n times 2 times this many number of C galaxies would be 2.0225 times 10 to the 18th. So the total universe for the total for the universe would be 6.045 times 10 to the 18th. Now we have to estimate the number of M hominids per planet. We'll say 3 billion. Right now, the Earth has about 7 billion. That seems maybe a little bit high. It probably stabilizes and decreases a bit over time. Same thing for the cosmic sector. So then we get the total number of M hominids would be 9.0675 times 10 to the 27th, and the total number of C hominids would be 9.0675 times 10 to the 27th. C hominids. Add those up and we get 1.8135 times 10 to the 28th total, or roughly 2 times 10 to the 28th for the entire number of intelligent, presumably at least quasi-ethical, human-like beings all around the universe, both material and cosmic. So that's our conclusion. Now, this being a database, you can, of course, change my numbers here to suit your taste. If you disagree with any of these, you can change it. No problem. All right. Well, that wraps it up for today. Please study the reciprocal system and prove it for yourself. The simplest possible treatment is my work, The Unmysterious Universe. It's available from Amazon.com and TranspowerCorp.com, just like all of my work. Has all the concepts, not lots of diagrams, very little in the way of equations. Very easy to read. Now, if you do want all the mathematics, please obtain my work, Existence and Interactions, a computational treatise of the reciprocal system, the true theory of everything. This contains 2 files, 711 pages in the PDF file, 711 slides in the PowerPoint file, thousands of equations, diagrams, figures, tables, you name it, it's in there. I'll keep you busy for months. Then, after that, you can obtain these two database modules. You see here on the left, this is the Macrocosmos database, and I'm going to close this right now. And close that. Back to the main menu, and you can see that we have the following layouts: the universe as a whole, galaxy clusters and groups, galaxy, star clusters, stars, planets, moons, minor bodies, nebulae, gas and dust, and voids. Has a great graphing package. Over on this side, you can see the Reciprocal System Microcosmos database menu. Covers solid matter properties, including interatomic distance, valence, specific heat, energy and entropy, thermal expansion, compressibility, electricity, electrical and magnetic properties, isotopes and spectra, liquid vapor and gas matter properties, volume and density, specific heat, energy and entropy, viscosity and surface tension, and electrical and thermal conductivity. Covers cosmic elements and subatomic particles, cosmic elements which are inverse to our elements, and therefore they are the mesons, according to conventional theory. And it covers material and cosmic subatomic particles, and of course we have photon properties. This also has a great graphing package. If you like economics, I have another software program called Optimal Economist, an implementation of Larsonian econophysics. This covers the economics, the microeconomics of individuals, businesses and business sectors, and the macroeconomics section, which covers the macroeconomics of countries and regions. Very complete. Keynesian theory has nothing like what we have. All right, well, that's enough for today. Please study the reciprocal system and prove it for yourself. Thanks for your attention.